Hello viewers, welcome back to my channel. In this lecture we will understand the basics of operating system. In previous lecture we have discussed about the introduction of operating system, types of operating system and functions of operating system. And before we can explore the details of how computer system operates, we need a general knowledge of the structure of a computer. So in this basics of operating system, first of all we will understand a computer system operation. Some basic knowledge of the computer system is required to understand how the operating system works. So therefore, a modern general purpose computer system consists of one or more CPUs and also the number of device controller connected through a common bus that provide access between components and shared memory. Now, for computer to start running, for instance, when it is powered up or rebooted, it need to have an initial program to run, and that initial program might be stored in the disk. For example, say our operating system is stored into the disk, right? So when our operating system stored into the disk controllers can control this device, and writing or reading to the disk can be controlled and done by this disk controller. Now what happens when something we want to read from the disk, this disk controller reads that data, and to display that read data from the disk to the monitor we use the system bus, right? So here all the devices, it might be USB controller devices, graphic adapter device, that is monitor, or disk, that is disk controller. So all these controllers connect through a common bus, that is system bus, which provides the access to the components, and also the memory controller. This memory can be accessed by all the device with the help of memory controller, and with the help of memory controller and with the help of the system bus you can send that data, retrieve the data through the system bus to device to the CPU. For example, operating system is loaded into the memory. With the help of system bus we can load the operating system from disk to memory. Any operation, input operation is performed by the user, is controlled by the USB controller, and that input data is transmitted to the memory with the help of system bus, because all the devices are connected through a common bus, that is the system bus. So through the system bus the data is transmitted from input to memory, and similarly any process which wants to occupy the CPU is again that process is transmitted from system bus to the CPU. After execution of the process, again that process is retrieved from the system bus to the respective devices. This is how this computer system operates. So all these devices are the computer devices. Now let us further understand how these controllers and all these system bus, everything works in the computer system. Now as I said, each device controller is in charge of a specific type of device. Means disk controller is the in charge of the disk, USB controllers are the in charge of mouse, keyboard, joystick, light pen, printer, etc., and graphic adapter controller is responsible for the monitor, projector, etc. Similarly, the memory controller is responsible for the memory. So these are the specific type of devices which get connected to a common bus called system bus. Now the CPU and the device controller can execute concurrently, computing the memory cycles. So the memory cycles are concurrently executed by the devices as well as the CPU. For example, say process 1 and process 2 is executing concurrently in the CPU. When P1 holding the CPU for a while, then P2 can go for the IO operations, and once the IO operations is performed by the P2 and P1 is completes its CPU operations, the P1 can release the CPU and it can go for IO operations, and P2, who has just now completed IO operation, can occupy the CPU. Right. So in this fashion, all the device controller and the CPUs can execute concurrently by the memory cycles. To ensure orderly access to the shared memory, memory controller is provided whose function is to synchronize access to the memory. Right. So synchronized fashion, all the memories are shared among the devices who needs the memory and those who wants to perform some function in the memory. Okay, so some of the terms we need to understand here. So before we proceed with the operations of computer system or operations with the operating system, so basics of the operating system can be understood with these three terms: the bootstrap program, interrupt and system call. First of all, understand what is bootstrap program. Bootstrap program means these bootstrap program are called as the initial programs. Why these are called initial programs? Because that runs when the computer is powered on or rebooted, means when you restart the computer or when you first time switch on your computer, this initial programs run in the memory of the computer, which is called bootstrap program. And this bootstrap program is typically stored in ROM, read only memory. As stated here, it is stored in the ROM, and it must know how to load the OS and start executing that system. Means when you switch on the bootstrap program, which is stored into the ROM, read only memory, which know how to start the computer, right, and how to load the operating system and how to execute the CPU. The bootstrap program must know how to load the operating system, right, and it must locate and load into memory the OS kernel. Means the OS kernel is loaded and located by the bootstrap program, because OS is stored in the disk, as I said, right, and when we switch on the computer system, first RAM and ROM gets executed. So whatever the data stored in the read-only memory, so read-only memory is as we know that we cannot make any changes in the data which is stored in the ROM, but that can be changed with the help of electronically erasable programmable read-only memory, EEPROM. So that general term is called as firmware. So it is available within the computer hardware, right? So we can change the content, but here whatever the content which is stored in the ROM, which is called as bootstrap program, that bootstrap program must know how to load the operating system from the disk to main memory and starts the system. right? So initially when you switch on the computer, we always say that it is getting boot. It is getting boot means the system is getting boot, means the boot program is executing, and it is loading all the operating system into its main memory and the kernel of the OS. This is the meaning of the bootstrap program term. Now second term is interrupt. Interrupt means what? When the CPU is interrupted, it stops what it is doing and immediately transfers the execution to a fixed location. What is mean by this? Fixed location means what? Fixed location means usually it is the starting address where the service routine is interrupted is located. That we can find in the next slide. So what is that fixed location and all? Okay. Now here just we will understand what is mean by interrupt. The occurrence of an event is usually signaled by an interrupt from either the hardware or software. We say interrupt means the occurrence of an event, any event which is generated or signaled by any hardware or software of a computer. If the hardware may trigger an interrupt at any time by sending a signal to the CPU, so usually by the way of the signal bus, which is called interrupt, right? So here we have mentioned that point, hardware may trigger any interrupt at any time by sending signal to the CPU. Now assume that CPU is executing the P1 process, right? P1 process is already in execution. Now higher priority process P2, when it enters, your hardware is interrupting the CPU and this P1 is resumed for a while, it stops for a while, and P2 is getting the CPU. It means that you are interrupting, right? So assume that you are working something or reading something, somebody knocked your door, room door, means that was the interruption. Interruption is happening, right? So interruption is happening means you are attending that guy who is knocking the door, and thereafter you are coming back, you are resuming your work, coming back to the same chapter, and you are continuing your study, right? That is the meaning of this interruption, and starting the address where the service routine for the interrupt is located, means we are starting from where we have left the study. So similarly, once the higher priority process enters the CPU, if the hardware may trigger an interrupt which is called the interrupt. If the this event or trigger is done by the system or a software may trigger an interrupt by executing a special operation called system call. System call means if an event or interruption is triggered by the software, then it is called system call or monitor call. This is the meaning of system call. You might understood the difference between this system call and interrupt. Interrupt means the trigger or event is done and signal is sent by an hardware is called interrupt. Triggering or signal is sent by the software is called as system call. When the CPU is interrupted, now currently the P1 is processing in CPU. Assume that when the CPU is interrupted, it stops what it is doing. So presently the P1 is getting executed or processed in the CPU. Now it stops what it is doing, means it stops P1, immediately transfers the execution to a fixed location. What is mean by fixed location? Fixed location means now the higher priority P2 is entering, means it will go to the fixed location. That fixed location is usually the contains the starting address where the service routine of the interrupt is located. So interrupt is this P2. This is the higher priority process which is entering, and interruption take place. So we will move to the fixed location. So that is the starting address of the P2. We will move to the starting address of the P2 where the service routine of the interrupt is located, where the P2 is located, right? The interrupt service routine then executes. Okay, the interrupt service routine executes means the CPU is allocated to P2 and the P2 gets executed. On completion of the P2, the CPU resumes the interrupted computation. Interrupted computation is the P1 computation, right? After completion of the P2 work, right, the CPU again allocated to the interrupted computation, that is P1. In this fashion, this operation of the interruption take place, and after the interruption process gets completed its execution in the CPU resumes the interrupted computation again. So this is what we have in this lecture. In upcoming lecture we will discuss the basics of operating system on storage structure. So thank you for watching.